To build an end-to-end data pipeline or ETL workflow, Snowflake does not have any orchestration utility or UI-based drag-drop tool. Rather, it gives different objects, and when we tie them together, we can build a robust data pipeline and automate the entire ingestion to transformation lifecycle. Objects like pipe, stream, and task, they can be used independently. When we combine them together, we can create a workflow. Snowflake does not have any tool for extracting the data, and it has to be done outside of the Snowflake instance. The data has to be moved under a cloud storage location before it is ingested into the Snowflake. Once it is ingested, then we can apply enrichment and then load the data to the consumption layer for end user analytics. In reality, ETL in Snowflake should be called ITL, as it allows ingestion using pipe objects, orchestration including CDC, and enrichment using stream, task, and standard SQL command. So, what you need to know more about the Snowflake ETL or ITL process: how to make pipe, stream, and task work together, how to integrate stream and task to make it work, how fast data move from left to right, means from source to consumption layer for analytics, how to ensure that the data is not lost and processed only once, what role does merge SQL statement play in this entire ETL workflow. So your Snowflake knowledge makes very little sense if you do not know how to make this component work together. So stay with me until the end of this practical video and practice everything about end-to-end continuous data loading workflow and learn many more interesting facts and limitation about ETL in Snowflake. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake data professionals. The last 18 episodes in this series already covered from history to architecture, data loading, micropartition, time travel, cloning, stream, task, and many more important concepts. This episode 19th, will primarily focus on end-to-end data processing technique using pipe, stream, and task within Snowflake. We will practice everything using Snowflake free trial edition and have a hands-on exercise to cover all the concepts listed in this slide. Let's understand the use case before we build the ETL pipeline in the Snowflake. We are going to take a very simple use case to understand the different Snowflake components and how do they solve our ETL problem. The customers, item, and order data is captured in the source system. The data must flow from source location, could be RDBMS database in your case, to the consumption layer in the Snowflake environment. Since Snowflake is a cloud data warehouse, the data from source system should be extracted and placed in an external stage. In this case, we are considering S3 bucket as an external stage. There is no way that you can load data without creating a stage. Once data is available in the external stage, we will ingest data to Snowflake Cloud Data Warehouse, and from here Snowflake components come into picture. Extracting data from RDBMS to S3 is not in the scope of Snowflake, and there is no native object provided by the Snowflake. Here we will set up SnowPipe object for each table and S3 notification services to load the data automatically every time a new data set arrives to S3 bucket. The item, customer, and the order raw data will be loaded into the landing zone. Landing zone table will have a stream object created, so every new arrival of data will be captured as a CDC. To move data from landing zone to curated zone, we will create task and task tree, and that will use merge statement to merge the data, update or insert or delete. We will also have stream objects created in the curated zone, so all the changes can be captured. Finally, we will build task in the consumption zone and load the curated data to the consumption layer, and sometimes it is also called analytics layer or model layer. Keep the technical complexity low, we will use WebUI to load the history data. We can call it first time data loading. However, in your project, you may load the first time history data via a different mechanism. We need to make sure that we create a stream object after loading history data, else a stream object will capture history data as a CDC. A stream object does not allow any enable or disable feature. Once it is created, it starts functioning. To process continuous data flow, we will load delta data manually to S3 bucket in the form of CSV files. There are many tools available, but again, for simplicity, we will do this process manually. Once the delta CSV are available in S3 bucket, we will set up notification services via SNS, so it can trigger a notification and invoke SnowPipe as soon as new CSV delta file arrives. To process and load the delta files, we will have pipe object created which will wrap a copy command. landing layer schema will also have a stream object created for each table so we can track the changes. Now once new delta data is loaded into the base table or in the landing zone, a stream object captures the CDC within the landing layer. The task and the task tree will trigger to load the raw data to the curated schema layer and enrich it as per the business requirement. Curated layer will also have the stream enable for each table respectively, so the insert, update and delete can be captured. Finally, the task or a task tree in the consumption layer will trigger and update the consumption layer with the latest data. And this is how we will make the data flowing from left to right and make it available without any manual intervention. And this ETL will work all the time as soon as the data arrives to S3 bucket. If your delta file is less than 100 MB and your processing is not very heavy, the data may reach within a minute from left to right. Now let's understand how we will load data and the object creation sequence. In any data application, we have to perform initial load and populate all the tables before we start our delta processing. In this example use case, we will use Snowflake legacy WebUI to load the data and populate the landing zone tables. We will use insert as select statement to populate the curated and consumption zone tables. Once the first time data load is done, then we will create a stream and task object and enable our CDC as well as continuous data pipeline. So make sure this is the order you have to follow in your project, else your CDC will be enabled in your history load or a first time data load and overall approach will not work as expected. Now let's understand the task and stream integration and how do they work. In the last two chapters, we have covered stream and task separately, but now we will understand how do they work and how the syntax looks like. We have seen this syntax in our previous chapter where we covered task in detail. If you have not seen my task tutorial as a part of episode 18, refer the description below for the link. Here we are going to add one additional dependency parameter with the stream. However, this additional line with when keyword says that the inline SQL statement will be executed only if my stream has data. If stream has no data or no CDC is captured, then the task will do nothing. So you don't have to write any complex logic to make the task executing or invoking the SQL statement for your CDC or a delta changes. It might look a bit tricky, but once you see all of them in action, you would be able to understand it clearly. Now you will have a question in your mind. For such a simple ETL, how many objects are created and in which order it has to be created? So let's decode that. This ETL involves just a 3 table at each layer. So we have total 9 tables. Data is moving from source location to S3 bucket to landing zone schema to curated zone schema and finally to consumption zone schema. Once we create all the table under different schemas, we will load sample data via WebUI to make sure that history data load is done, or we can call it first time loading is done. Next, we will create 3 stream objects for each of this landing zone table called item stream, customer stream and order stream. They will track any changes to this table. Once it is done, then we will create 3 tasks and we can possibly make a task tree or we can schedule them one after another. They will run on every first, second and third minute, or we can create a task tree and they will consume CDC data from stream object and populate respective table under curated zone. Now curated zone also need 3 stream object for item, customer and order table respectively. To consume delta data from curated tables, consumption table also need a task or a task tree which will again run according to our frequency. They would read the delta data from the curated zone and move it to the fact and the dimension table within consumption zone. So if you calculate, we need 3 pipe, 3 tables, 3 stream under landing zone, 3 tables, 3 tasks and 3 stream under curated zone, 3 tables and 3 tasks in the consumption zone. Total 24 objects for this structure and for this pipeline. We may need a stage object and a file format and maybe a few sequence object if required. And that's why there are so many tools available in the market to simplify this complex ETL approach in the Snowflake. And you can imagine if you have hundreds of tables, it will really be a complex Snowflake project with respect to design, implementing it. And just knowing object creation will not make you a proficient Snowflake data developer. Before we move to the next section, I have an important question to ask. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I think you should be. There is a lot of great opportunities out there if you know Snowflake Cloud Data Warehouse. I have been adding a lot of videos to help the Snowflake community to learn Snowflake besides Snowflake certifications. The feedback I got from my audience way high than my expectations. Folks are getting certified at first attempt and scoring close to 100%. Data engineers, leads, architects, and even data managers are learning from my free content. You don't need to buy any expensive courses. Check my playlist. It includes complete hands-on Snowflake guide, SnowPro certification guide, important mock questions for certification, key SQL function series, Snowflake Python and connector series, and many more videos are on your way. So press the like button if there is anything valuable in this video for you. So let's practice it together. Now open your Snowflake free trial edition and let's learn everything what we have spoken so far. This is going to be a very interesting hands-on session. You can find all the SQL script used in this video in my website. Find the link in the description below. I am here in my free trial edition and using a Snowflake legacy WebUI. I will also switch to the Snow site on and off. There are total 6 different sections and I am having a worksheet for each of them. We are going to talk about a lot of SQL statement. Please pay attention and drop your questions and queries in the comment sections if you have any. Let's understand what we are going to do first. In the part 1, we will create 3 logical layers or zone. You can have all the table under a single schema, but to make sure that we follow a layered approach, I am going to create 3 different schemas here. Then I will create 3 tables under the landing zone schema. I will load the initial data via legacy WebUI, and then finally I will verify the tables and the data. So that would be our part 1. So let's create 3 schemas called landing zone, curated zone, and consumption zone. So it got created. So I got my consumption zone, curated zone, and landing zone schema. They are all under my database called CH19. Right now I am using the role called account admin for all my operations to make sure that I don't get into role issues. Step 2, I am going to create order, item, and customer table within the landing zone. Landing zone tables will be transient table. We have seen in chapter 9 and 10 that what is the purpose of transient table. All the fields in these tables are varchar and not having any specific data type to make sure that we load all the data in the landing zone. So I am using the schema called landing zone. So my schema got changed. So I can see I am having a database CH19 and schema is landing zone. So let's create this table called item table, which has item ID, item description, start date, end date, price, item class, and item category. My landing item table got created. Next, I am going to create a table called landing underscore customer, which has a customer ID, salutation, first name, last name, birthday, birth month, birth year, birth country, and email address. This is also a transient table. Finally, I'm going to create an order table which had an order date, order time, item ID, customer ID, and many other fields. All of them are varchar and it is also a transient table. Let's see how this table looks like. They must be empty. There would not be any data within them. So I can see all my tables are created successfully under database CH19 and schema landing zone. They are all transient table and they don't have any data set available right now. Looks good. Now, before I load the data via legacy WebUI, I have to create a file format and it will skip the header column and it will load the data. This file format will also be created under the schema landing zone because file format is an schema level object. File format is created successfully. Now I'm going to use the legacy WebUI and load the data. Before that, let's see how the data looks like. Here you can see I have this order history table which has 10K record. This is my header. Next, if I go to the item, I have again a header which is item ID, item description, start date, end date, and all those things. And it has roughly 2.7K item entries. And finally, I have this customer data where I have this header called customer ID, salutation, first name, etc. And I have roughly 8.8K of customer entries. I am going to load this data set via legacy WebUI. To load the data to the legacy WebUI, I have to use the database icon. I am selecting my database. And I can see I have a 3 table available here. I am going to select each of them and I will start from my order table. and I click on that, select the load data, and that is how I will do that. I'm selecting a file, moving to the next. Under this schema, I have only one file format, so it has pre-populated this, and I'm going to load the data. I got a successful message, data is loaded. I will follow the similar approach and fast forward to load the customer and item dataset. I can see here the 10K rows loaded. Here it is 8,886 rows loaded on a customer table, and I have 2,790 rows loaded on the item table. Looks good. So our first time data loaded successfully. Let's run the show tables. I can see the number of rows and in the respective table. So looks good. So our initial data load has happened successfully. Now let's see the data quickly. Customer data looks good. Item data also looks good. And order data also looks good. If I have to see my loading history, I can go to the Snow site and check the loading history too. Let me switch to the Snow site console. So here I can see my consumption zone, curated zone, and landing zone side by side. I can go to the item table, copy history, and it shows that data is loaded on a 5th March. Here it shows that order data is loaded. So this is how I can check my loading history from the Snow site. This feature is not available in our legacy WebUI. If you have not seen my Snow site tutorial, please go to this episode and watch. So we have completed the part 1 exercise. Data is loaded into the landing zone schema, and item, customer, and order tables are populated with the history load. In the part 2, we will create tables under curated zone and load the data from the landing zone to the curated zone as a one-time load. We will verify the tables and data in the curated zone. To load the data from landing zone tables to the curated zone table, we are going to use simple SQL statement. Now I'm in a worksheet 02 curated zone tables. Here my first step is to change the context. So I switch to the curated zone schema. Let me verify that. So I am in my CH19 database and schema is curated zone. Good. I'm going to create a table called curated customer. It is having exactly the same set of fields. However, each of them are having an appropriate data type, plus it has a customer PK as an auto increment field. Let me create this table, and this is also a transient table. My table is created successfully. Similar approach I will follow for curated item. It also has an item PK as an auto increment field, followed by all the fields which are available in my landing item along with the appropriate data type. My curated item transient table is created. My last table in curated zone is curated order. This is also exactly the similar structure along with order PK as an auto increment field. And all the fields are having appropriate data type, whether it is varchar or a number or a decimal. Let's see all the table under curated zone schema and validate them. So I can see I have no data available. The tables are created under curated zone. All of them are transient table. Now we will simply run an insert as select statement and load the data from landing zone. Here we will not have any transformation. In real data project, you may add some additional metadata or transformation logic. However, for simplicity, we will not do that. To keep the logic simple and show the technical flow, I am running a simple query, and this is how it looks like. So moving all the data from landing customer to curated customer, this is the query. Insert into curated customer. I have selected all the fields and I am simply selecting all the data set from my landing customer. That's it. So it has inserted 8,886 records. I am applying the same logic for item table where I am selecting all the data set from landing item and inserting them into my curated item. So no specific transformation done here. I can see 2,790 records are loaded. Good. Finally, I am moving all the data from landing order to the curated order by following the same approach. So I am selecting all the data from landing order and inserting into curated order. So 10,000 rows got inserted into my curated order. Let's validate the data set. And I can see all the data got populated with rows. To make sure that the byte size and the rows are exactly same in all those tables, I can switch to the database tab. And here I can see exactly the same data set available. Only difference is that in each of these curated tables, we have one additional column called primary key, and that's why you can see the data size is slightly different here. We have seen that how data is stored in Snowflake using a micro-partition, and if you have not seen my micro-partition chapter, please refer the link above. This is one of the most important foundational chapter which I think every Snowflake developer has to understand. So part 2 is completed. We have created 3 tables under curated zone: item, customer, and order. We have also populated data as is from our landing zone to the curated zone, and the history data is now available within the curated zone. We have validated the number of rows. We have only added one additional column called PK auto increment for each of these respective tables. We'll move to the part 3. Part 3, we will create tables under a consumption zone schema. Sometimes it is also called analytics zone or modeled zone. We will load data from curated zone to the consumption zone as one-time data load. And finally, we will verify the tables and data under different dimension and the fact table. In your case, you may name it in a different way. However, in a traditional data warehouse world, we call it dimension and the fact tables. Customer and items are master data, so they would be available as is. However, the order fact table will be aggregated on the day level. So let's jump into WebUI. I'm going to create item and customer dimension table followed by order fact table, and that is how the order I'm going to follow that. Again, there are a lot of business logic can be applied, but I'm just keeping it simple to demonstrate the flow of our data. So first, let me switch my context. I am using database CH19 and consumption zone as a schema. Now this is my item dimension table, and this is not a transient table, this is a permanent table. It is having an item dimension key as an auto increment key, followed by other field from the item table which we have seen in curated and landing zone, and I have added some additional metadata field. Your project may have a different requirement. This is how my item dimension table looks like. So my item dimension table created successfully. Moving to customer dimension, this also has a key called customer dim key, and followed by some of the important fields, and other fields are carried forward from landing to curated zone to consumption zone, added, updated timestamp and active flag. So my customer dim is created successfully. Now third, we are going to create a sales order or order fact table having a dim key as a part of it. Some of the fields are omitted from the order table for simplicity. So my order fact table is also created. It is keeping all the fact available, and I am just having the customer dim as a reference key and item dim as a reference key. All the data is aggregated at the date level. Now let's validate the table using show command. I can see customer dim, item dim, and order fact are created, and none of them are having any data set available. Looks good. All of them are permanent tables, not a transient table. So good. Now let's load the first time data using a simple SQL statement. So item data from curated item table to the consumption dim table is pretty straightforward. 2790 rows inserted as is. My customer table query is also very simple. I am selecting all the data from the customer table and inserting into a customer dim table. 8886 rows inserted, looks good. Now to load order data from curated order to consumption order fact table, here we have to join the data and we have to do the aggregation at a day level. So this is how I am inserting into the order fact table. Here all the data is aggregated on the order date, followed by customer key, item dimension, and order count, order quantity. The query is pretty simple. It is aggregating the data on order date, customer dimension key, item dimension key, and it is joining with customer dimension and item dimension along with curated order table. Let me run this query and we will see the number of data inserted into this table. So 5739 record got inserted. Let's see all the tables. So we have customer dimension, item dimension, and order fact table. And we have 8886 rows on customer dimension, 2790 in my item dimension, and 5739 on my order fact table. And this is how my order fact table looks like. So I'm not much validating the quality of the data. I just wanted to show how we have to load the first time data set as a history load. One thing I would like to show in SnowSite page, when you copy the data using the insert statement via an SQL command, you may not be able to see the copy history. And this is how it looks like. Customer dimension table has not got the data through the copy command, and that's why the copy history is empty. However, when I go to the landing zone where data is being copied through the copy command, you would see the copy history. Here I can see the copy history and all the copy history details are available. So we have completed loading data to our landing zone, curated zone and consumption zone. And you can see we have 2790 record in item table in each of the layer. We have 8886 record for customer data in each layer, and we have a 10K order data in landing zone and curated zone, and on the consumption zone it is aggregated and the total number of rows is 5739. So this is how the current state looks like. Let's go to the part 4. In the part 4, we will create stages and pipe in the landing zone and verify the S3 bucket plus notification services whether it is set up properly or not. These 3 stages and pipe will be created in the landing zone, and that's why I am switching my context to the landing zone schema. I can see my database is CH19 and schema is landing zone. Good. If you have not seen my chapter 11 for external stage, here is the link and you can go and watch this video if you have any doubt about creating external stages. I am going to create these 3 stages called Delta Order S3, Delta Item S3 and Delta Customer S3. And here the path is Delta followed by orders, Delta followed by items, Delta followed by customer. You can also follow a file pattern. However, for a simplicity, I am keeping 3 different folders. Let me create all those stages at one go. So my external stage is created successfully, which is pointing to my S3 bucket. Let's list all the stages. So I can see my Delta customer, Delta item and Delta orders are created, and these stages are created in the landing zone. Good. Now let's create pipe object to push these Delta via copy command. Make sure that each pipe must have an auto ingest flag true, else the auto ingestion will not happen. And your instance must be running in AWS Snowflake environment. Otherwise, you will not get the ARN number for the SNS. If you have your Snowflake instance running on Azure or a GCP, then probably some of the steps specified here may not match. So I'm going to create the order pipe first. And this is how the syntax looks like. It wraps a copy command which will copy the data into a landing table from Delta orders S3, and the file type is CSV. And the pattern is only the file which has the word order followed by the CSV as the extension. And in case if there is any error, it will continue and process the rest of the record which doesn't have error, right? If you would like to know more about the pipe, please refer the previous chapters. So let me create this pipe. So my order pipe created successfully. Now I'm going to create item pipe, exactly the same syntax. Only thing is that it is pointing to the Delta item 3 S3 and it is going to copy the data on the landing item. Here also on order it will continue, and the file pattern it will look for items. Finally, I'm going to create customer pipe and it has exactly the same syntax. It will copy the data from this Delta location to landing customer. So all my pipes are created. Let me list the pipe for you. And here is my pipe. And if you see, all the ARN number looks exactly same. So for any Snowflake account, no matter how many times you create the pipe object, the ARN number would always be same. And it is very, very important to understand that your copy command should have either the file pattern or having a right folder name, else it will start copying everything which comes into your stage location and it will end up on error. Let's check if these pipes are running properly or not and validate their status. So my order pipe is in the running state. Good. My item pipe is also running state. And my customer pipe is also in a running state. So now let's review our S3 setup and notification setup in the AWS. If you have not watched my previous videos how this setup works, please refer the episode 10 and episode 11. Here I am in my S3 bucket and this is the folder called Delta. I have 3 folders called customers, items and orders. Let's validate whether they are having dataset or not. Let me click on the orders table. Here I do not have any data available in my orders folder. Okay, now let's validate the notification. For that I have to go to the root location. And here all my event notifications are already available. Okay, and let's see how this event notification looks like. So here I have given for item, I have given I. It says delta items and suffix is .csv. Whenever a delta data comes to the item folder having an extension with .csv, a notification will trigger. Right now I have given all object creation will do the notification. And here my options are SQSQ. If you look into this SQS ARN, this matches with my ARN available on my Snowflake. And this is how my setup looks like. So our stage setup is done, our pipe setup is done. We have verified our S3 bucket folders and we have also validated our notification services. So our part 4 is complete. Now we'll jump to the part 5. So the part 5, here we are going to create a stream under landing zone schema. So before we put the delta files into our S3 location, we have to make sure that streams are created under the landing zone and the task is set up in the curated zone. So we will create a stream under landing zone for each of the table. Then we will create task under curated zone and then we will resume the task and validate that they are running under curated zone. Remember, cross schema task linking is not possible. Task from one schema cannot call task from other schema. This is what the limitation as on today. So let's go to our WebUI. So as I mentioned, before we load any delta data, we have to enable the stream object and stream object will be append only. I change my context. Let me revalidate that. Okay, database CH19 and schema is landing zone. Creating 3 stream named item stream, customer stream and order stream. And all of them are append only. And for that, I have to have this flag append only equals to true. So my landing item stream is created successfully. My customer stream is also created successfully. And my order stream is also created successfully. So this is how my stream looks like. And they are all delta, no stale and append only. Looks good. Now step 2. So let's create task. Here first we will create a task which is called order curated task, and this will run on every 1 minute and it will only execute the SQL statement when we see data into the landing order stream. Okay, before that I will change the context because the task has to be created into the curated zone. I'm in the curated zone. We know the stream only captures the delta. So we have to make sure if I am getting a change record, that has to be updated into my curated table. And if the data is a newly arriving data, then it has to be inserted. And this is how the merge command looks like. So what it says that merge into my curated order table using this statement. If my stream using this stream object and if the order date, order time, item ID and item description, if all of them are matching, in that case, this is the same order, but this order is coming with some change. And in that case, I will update the dataset. And here all the data is coming from stream object and it is setting the customer ID, salutation, rest of the detail into the curated order table. If it does not match, then insert the record because this is treated as an update and this is an insert statement. And that is how the merge statement works. So this is a long SQL. You can refer my website to get this SQL. One important thing to remember, this task is created under a curated zone. You have to give a fully qualified name for your stream object. Otherwise, it will assume that the stream object also belongs to the curated schema, but that is not the case here. So I'm going to run this. So my order curated task is created successfully and right now it is in a suspended mode. Now I am creating exactly the same way customer curated task. This will run on the every second minutes because first I will get the order data, then I will get the customer data, and then I will get the item data. You can have your own frequency according to your business need. Here, how do I know whether it is an existing customer and update is required or it is a new customer? For that, I am going to join my curated customer with the stream object. The difference is if the curated customer ID matches with the stream customer ID, it means that this customer ID already exists, and if so, then update the customer information, and if it does not match, then insert the record. Okay, so let's execute this task. So my customer curated task created successfully, and the third task is called item curated task. This will run on every third minute. I can create a dependency that item and customer task will run only after the order task, and here I can give a statement called after the name of the customer. But in this case, I am keeping it simple and not creating a task tree. And this will run on every third minute from the time it is resumed. This will only execute the following SQL if the landing item stream has some CDC data, otherwise not. So this is how the merge statement looks like. If the item ID, item description, and start date, if these three things matches, then it will update the end date, price, item class, and item category. And if it does not match, then it will simply insert the record from taking the data from the stream object. So let me execute this. Now let's see how the task looks like. So I can see my 3 tasks created. Each of the tasks is having a task ID. They are under curated zone, and this is going to run first minute, second minute, and third minute from the time it is resumed. And all of them are right now in the suspended state. All of them are executing a merge statement, and they are on condition. So if I do not have any CDC, this merge statement will not be executed. If I have the CDC data, then only the merge statement will be executed. Now, so I'm going to resume this task. So all got executed successfully, and let's check the history. So I can see they are all scheduled, and this is going to execute in 21, 22, and 23 minutes, one after another. So it is start with customer order, order customer, customer, and item. This is how it is going to be executed. Now let's see how this stream and task looks like into our SnowSQL. So the stream comes under a data pipeline, and here you can see that I have a customer pipe, item pipe, and order pipe, and I have landing customer stream, landing item stream, and landing order stream. In the same way, when I go to this data pipeline under the curated zone, I can see the task. This is called order curated task, item curated task, and customer curated task. If you click on that, it shows that it is scheduled in every 2 minutes. It has a condition called stream, and here you can see the entire SQL script. How does it look like? Let's go and see the item curated task. So this runs on every third minute, and this is how the SQL looks like. For the order, this runs on every 1 minute. It has a dependency on my landing zone order stream. And this is how the task definition looks like. So this is slightly more complex. So here we end our part 5, where we have created 3 streams for each of the table. We have created 3 tasks, and each of these objects are created in a different schema. So the streams are created in a landing zone, so they will capture the new data arrival as a CDC in the landing zone. And since my task will insert the data into the curated zone, they are created in the curated zone. However, you can create the stream and task under the landing zone, and there is no such restrictions. You can certainly do that. Let's move to the part 6. In the part 6, we are going to create a stream under the curated zone schema. We will also create task under the consumption zone schema. We will resume the task and validate that they are running under consumption zone. So this is exactly the same process what we have done between landing zone and curated zone. Now we are doing it between curated zone and the consumption zone. So here I am in my WebUI. To create the stream in the curated zone, first I will change my context to curated zone. All good. Database CH19 and curated zone. So I'm going to create a stream on curated layer for item, customer, and order table. I can see my streams are created, and here I am not creating a stream which is append only, because I can have update as well as I can have insert into my curated dataset. So that is the difference between the previous stream what we have created versus the stream which I have created into the curated layer. Now you may have a very different business case, so you can apply the append only or the delta stream according to your need. Now I am switching to my consumptions zone before I create a task. So we will first create the task for the dimension table and then we will create the task for the fact table. So customer and the item would be the dimension table, which is nothing but a master data set. So the statements are pretty same. However, there are slight difference because in this task, I am going to use the metadata operation as a validator. So this is the name of the task called item consumption task, which will use warehouse compute warehouse and it will be scheduled on every 4th minute. It will only execute this merge statement when the curated item stream has a CDC data, else it will skip the execution. And the merge statement says that I am going to merge data between item dimension and the item stream from the curated layer on this 3 criteria. If my item ID matches, if my start date matches, and if my description matches. When it matches, and if the action is insert and true, in that case, it is an update statement. Okay. And if it matches with the delete and the update is false, then set the active flag equals to no. In your case, you may have a very different business rule. And if it does not match and the insert is not part of the update, then you have to insert the record. And if you do not understand how this thing works, if you do not understand how this metadata information works, please watch the chapter 17 and I have covered everything in detail. So this is how this metadata plays a very important role. Let me execute this consumption task. This got executed successfully. Next, I'm going to create a customer consumption task which will run on every 5th minute, and this will execute the merge statement only when curated customer stream has a CDC data. So if the record matches, if it is the same customer ID, and if insert is true and update is also true, it means that this record is updated. So I will update all the necessary field. If it matches, but if the flag is false, if the customer exists into the dimension table, it is tagged as a deleted into the stream object, then I have to set the active flag equals to no. And if it does not match, it is a new customer which is arriving and I will do the insert. This is how the customer dimension CDC will behave. Let me execute this. So my customer consumption task executed successfully. Now my last task is called order fact task. Here I am not going to use any merge operation. For a simplicity, I am tracking if there is any change in the order table or not, and I am running the insert override because it is an aggregation. I cannot apply a simple update statement. So to keep the overall complexity simple, this task will run on every 6th minute and it simply run the aggregation what we have done as a part of one-time load. So if the customer matches with the customer and the item matches with item ID, item description, and end date is not null, then it will go and perform the aggregation. This is not a very valid implementation, but I just wanted to demonstrate how you can really move the data from one end to another end. So my order fact is also created, and let's go to the Snow site to validate them. So when I go to my Snow site, I can see that I have a 3 stream: curated customer stream, item stream, and order stream. Let's see how do they look like. So they are all delta type and it's a pretty straightforward, no complexities. And let's see how the task looks like into the consumption zone. First, start with item task. It will trigger on every 4th minute from the time it is resumed, and it will execute the task definition only when there is a dataset available into the stream. This is how the task definition looks like. Customer task will run on every 5th minute. If customer matches between dimension table and the stream, and if it is in a part of update operation, then it will update all the fields. If it is deleted, then it will set the flag to no. And if it is not matched, then it will insert the data. For the order fact task, it will run on every 6th minute. It does not perform any merge operation. It simply performs insert override into. Now we have validated. Quickly resume the task. All of my tasks resumed successfully. Let's go and validate them. So I can see item, customer, and order fact, they are all scheduled following a merge, and insert override statement. Their next scheduled time is like 45, 46, and 47 minutes. This one. Good. So we have pretty much completed the part 6 where we have created 3 stream, 3 tasks, and we have enabled the task and its streams are functioning properly. So if you look into this slide again, we have created 3 pipes, 3 tables, and 3 streams under the landing zone. We have created 3 tables, 3 tasks, and 3 stream under the curated zone, and we have created 3 tables and 3 tasks under the consumption zone. And that is how we ended up around 24 to 25 objects for this ETL process. Now, our next task is to load the data. It flows from the point the data is ingested until the consumption zone or not. And if I look into the data set, this is how the data set looks like. Item 2790, customer 8886, order it start with 10K and finally it ends with 5739 because it is at aggregated level. Let's start with part 7. Before we really start our continuous data loading via S3 bucket, we must check with very small data file to make sure there should not be any compilation or setup issue. So for that, I will load 2 delta file for each of the table having one record. So to simulate that, instead of loading the data from S3, I am going to load the sample data file using WebUI. So for that, I am going to load 2 delta file for each table having one record each and make sure that overall flow is working without any SQL compilation issues or without any setup issues. Once it is validated, then I will move to pump more delta file from my S3, which will bring the data via SnowPipe, and then my CDC will trigger as this picture. So here you can see I have a order delta 01 which has just one record. I have an item delta 01 which also has a one record, and I have a customer delta 01 which also has a one record. I am going to validate the entire flow by using one record for each of the table, and if it works fine, then I am very sure that my continuous delta load will function from S3 bucket. So I am in my web UI, and let's go to the database tab to load the data. From here, first I will load the order data followed by customer and the item data. Select one row from the list and click on the load button. I will fast forward this data loading process. We have already seen the data loading process in our history data load. So this data loaded successfully. This also got loaded successfully. And finally, this also got loaded successfully. The delta file having one record for each table got loaded successfully. So all the delta file got loaded successfully, and I can see the number of rows in each table got added by one additional row. Now, data should go automatically via stream and task to curated zone first, then to consumption zone as a part of workflow, which is created using stream and task. I can see the order data has come, customer data has come to curated schema, but item data yet to come. So let's wait and refresh our SQL command. Let's check our item stream to see what's happening there. Looks, the stream still has one record and it is yet to be consumed by the item curated task. Now I got this task executed, so let me go back and check if stream is still having the data or it is consumed. It looks it is consumed. So let me run the show tables. Now I can see one record from each table automatically moved from landing schema tables to the curated schema tables, and this has happened through my stream and task. I can see 8887 in customer table, 279 in item table, and 10,001 record in order table. Each of them got one additional row through the delta process. So stream and task between landing zone and curated zone is working fine. Now let's move to the consumption zone schema and see what's happening there. I can see the customer dimension data got added and it changed from 8886 to 8887. Item and customer data yet to be added. Since each of them is running in 1 minute interval, we have to wait. Now I can see the item dimension got added, but order data has not yet updated. Now, when I refresh the task history query, I see an SQL error and let me investigate and bring the fix for you. When I look into this order factor task, it is trying to insert override into a table which is called task fact. However, this is not the name of the table. When I check it, the name of the table is order fact instead of task fact. So let me correct that mistake. Before I recreate the task, let me suspend and recreate the task and resume it again. So my task is created successfully. Now it must insert appropriate data. I resume the task and I will wait for some time task to get executed. So if I look into that, I can see that it says insert override ch19 consumption zone dot order fact and it got executed successfully. Let's see the record count. The record count is 5740. It was earlier 5739. It means that it is working appropriately. So with one delta file having one record in each of the table, the data is flowing appropriately. Now here I am going to load another delta file called order delta02, in which this is a new order and this order already exists in our system, which I am going to modify. And I have this customer data where my first customer is a new customer, but the second customer is an existing customer. On the item delta, this is a new item and this is an existing item. So let's see how the update as well as insert works together. So I'm going back to my database tab and perform an upload operation. So first I will start with the order table. So I will quickly load order, customer and item dataset to the landing table. So each of these dataset has got two additional record. So order table has got 10,003 record. Item table has got 2793 record. Customer has got 8889. It was 8887. Now it has got one new record and this one. Good. Let's check this stream if data is processed or not. So I think data is processed. Here also data is processed and the data is processed. Let's go and check the curated zone. So one record got updated. Now it is two, one updated and one inserted. Good. This is also 2792, one updated and one inserted, and customer got 888 this here also. So this is perfectly fine. So first I will try customer dimension. So it has got total 888 record, looks good. Item dimension looks good. And the fact is still 5740. So we need to check why. Maybe it is yet to run. We have to wait for another 2 minutes to have this functioning. So I can see my data is executed 5741. So good. So now my overall data flow is working appropriately. In the next part, I'm going to push the data through the S3 bucket just to make sure that whether data is being updated or not. So this is the customer record which is updated for this particular email address, and this is the item ID. This is updated for these two values. Let's go back to the WebUI, use the time travel feature and understand the changes. Here on the customer dim, I am firing the same query using the offset value as well as the current value, and let's see what result does it bring. So here I can see they have got exactly the same customer dimension value. Everything is same. However, this email address is different. So current value is com. Initially it was edu. Now if I fire the same query on item dim table, the item which we have changed, let's see what result does it bring. Here I can see it was initially 0.81 price followed by loose stones and jewelry. Now the current price is 6.41 tennis and sports. Now my update as well as insert both are working. I am in my S3 console and we have verified that none of the stage folder has any data available. So we can load fresh delta file for processing. Let's check our delta order folder and I don't see any delta CSV file here. All good. Likewise, delta item folder is also empty and in the same way, delta customer folder is also empty. So none of the folder is having any CSV delta file. Let me use the S3 upload function from AWS console and upload the delta dataset to the respective folders. I will fast forward from here and complete the upload process in the background and come back. So I pushed one delta file under order delta folder in the S3 bucket and it has 5000 entries. I also pushed item as well as customer data file. They are all non-compressed CSV format. We already have the SNS notification setup working and SnowPipe is also active in our Snowflake environment. Let's go and check the Snowflake WebUI and see if data is being loaded by now or not. Before we validate the data loading, let's verify how much data we had it. We had 10,003 order records, 2,293 item records, and 8,889 customer records in our landing zone schema tables. That includes history load plus 2 delta file for each of the table via WebUI to perform the sanity check, and they all worked well. Let's run the landing order table and see the result. So we see here we got 15,003 orders available. It means those 5,000 record got added to this table via pipe object. Let's check the landing item and it shows 4,088 rows. And finally checking the landing customer table and it shows 13,289 records. So we are all good with that status. So all the delta non-compressed CSV file loaded to the landing zone schema via SnowPipe objects. Now let's check the copy history tab for respective table via SnowSite. Let's check the landing order table and check the copy history. I can see it has 5k records added via pipe. When we see the copy history tab, we find 3 additional entries here. The first data load represents the initial history load. Other 2 delta file we loaded for testing purpose. So that's how it stands. Total 4 data loading via copy command. This is how the data loading can be traced via SnowSite, which used the copy command to load the data. Let's go to landing customer table and check the copy history tab. I can see a partial loading and out of 4,445 rows, only 4,400 rows got added. It has some Unicode character issues. You can click here and check the error message. Now let's check the landing item table. Item delta data got loaded successfully without any issues. So all looks good from the SnowSite console. So my S3 to landing zone data flow is working fine without any issue and the overall flow through the SnowPipe is working fine. Now let's go to the curated zone schema where data is expected to be loaded via stream and task. First, I will check the order table as this delta data was loaded first. You can see from summary, it has got 15,003 rows. So data got loaded via stream and task to this curated order table. In my curated item table, I have 4.1k rows and curated customer shows 13.3k rows. So all these 3 tables in curated zone schema loaded successfully without any issue. If we check the copy history tab for curated zone schema tables, the copy history is not available as data is loaded via stream and task through SQL commands and it did not use any copy command. So moving to the consumption zone schema and let's check the load status. First, I will check the customer and item dimension table. Customer dimension table shows 13.3k record and item dimensions table shows 4k rows. I am not really validating all the rows as some of them might be treated as update and rest of them are treated as an insert statement. In order fact table, we got 5007k rows. So all these 3 tables got updated successfully and my setup for stream and task in this layer is also working without any issue. Now let's validate the task if they are running appropriately. Looks they are running without any issue and merge statements are working fine. Task run every time and merge statement will be executed only if streams are having any dataset available. If not, it will be recorded as skipped. I can see that curated order task merge statement here and it executed successfully. Next, my customer curated task, it also got executed successfully. And I have item curated task and this also got executed successfully. So all the tasks under the curated layer are working fine. You can also notice that all the SQL statements which are part of the task are recorded here. So you can go and you can check for your later analysis via the task history table function. My order fact task executed successfully with insert override. Item dimension task is also executed successfully and customer dimension task is also running fine. So all good so far. The end-to-end flow from Delta data moving to S3 bucket and it is arriving to the consumption zone layer is working fine even for a large data set via external stage using pipe, stream and task object together. Let me push some additional Delta data set and see how does it work. So I pushed some additional Delta dataset for orders, for items, and the customer. And let's see how do they look like, whether they are processed successfully or not. When I go to my SnowSite web page, let's start with the order table. Here I can see my Delta 3, Delta 4, Delta 5, and Delta 6. All 5000 records are processed and they are processed through the order pipe. Looks good. Item data is also loaded successfully. It has only got 3 additional Delta files 03, 04, and 05. When I go to the customer table has some issues. 03 and 04 partially loaded. 05 file is failed for some reason. Let's see. It has some Unicode issues for all the 104 rows. So it has been completely rejected. And this is how the color code looks like. And you can come to this screen and check which all dataset have failed and which all data executed successfully. So this is how your overall continuous data loading will work in Snowflake using external stage, pipe object, stream object, and the task object. Hope you have understood how a very simple ETL workflow works in Snowflake. Now, when you have to create so many objects across multiple schemas and for a complex data project, you must know how the role and the role hierarchy works in Snowflake. Else, managing a large data project in Snowflake will be a nightmare. So, the next episode, the episode 20, will talk about role and role hierarchy in the Snowflake. And one of the most important chapter if you want to learn and build a secure enterprise grade Snowflake data project. I hope you have been enjoying this Snowflake learning series. And if there is anything you liked in this session, press the like button and leave a comment. So, happy learning.